Welcome to this lesson on recursive sequences. Recursive sequences are those in which we use one or two previous terms to help generate the next term in the sequence. One of the more famous sequences you've already learned about is the Fibonacci sequence, where we use the two previous terms to help generate the next. For the beginning of the sequence starts off as 1 and 1. So 1 plus 1 gives you 2. 1 plus 2 gives you 3. 2 plus 3 gives you 5. 3 plus 5 gives you 8. And the sequence will continue. We're going to focus on recursive sequences that use a formula. Some key points to remember is that recursive sequences always use the previous term in the sequence to help generate the next term. Anytime you see this a with a subscript n minus 1, that is the indication of where you plug the previous term in. In each one of these formulas, you will always be given the first term, a sub 1, to start with. You'll use that first term to help you generate the second term. Once you know the second term, you'll use that to help you generate the third, and so on. Let's dive into the first example. It says to find the first 5 terms of the recursive sequence, where a sub 1 equals 4, and a sub n is a sub n minus 1 plus 2. What we know here is we know the first term of the sequence is 4. We're going to use that as we try to come up with the second term of the sequence. Remember from the previous screen, this a subscript n minus 1 indicates where we're going to plug in our previous term. First term of the sequence was 4, so I'm going to plug in 4. Continue the equation with the plus 2 at the end. 4 plus 2 means the second term of the sequence is 6. Now we need to find the third term of the sequence, or a sub 3. We use the same location of where n subscript n minus 1 is. We need to plug the 6, that was our previous term, into that location to help us find the third term of the sequence. So I'm going to replace that with a 6, add 2. The third term of the sequence is 8. We'll continue as we go to the fourth term, plugging in 8 in that same spot. The fourth term of the sequence would be 10. And the fifth and final term that we are to find, we would replace that spot with a 10, add 2 to get 12. So in this recursive sequence, we were given the starting point of a sub 1, and we used that, we plugged it into our equation, our formula, to help us generate the next term. Let's take a look at example 2. Example 2 is a little bit different. We want to find the first 5 terms of the sequence. A sub 1 equals negative 1. A sub n equals 3. Whenever this indicates multiplication, even if it doesn't have a symbol in between it. So it's 3 times a sub n minus 1 minus 2. So what we know is the first term of the sequence is negative 1. We need to find that a subscript n minus 1. This is the location of where we're going to plug in our previous term. So when we want to find the second term, the previous term is negative 1. So we have the 3. I'm going to plug in negative 1 where the a sub n minus 1 is. Then continue the formula with minus 2. And we do some calculation. 3 times negative 1 is negative 3. Minus 2 leaves us with negative 5. To find the third term in the sequence, we need to use the previous term of -5 and put it in the same spot where we put -1 when we were finding A2. So we have 3 times -5 minus 2. That's -15 minus 2 gives us a -17. Two more terms. The fourth term, we're going to replace a sub n minus 1 with -17. So 3 times -17 gives us a -51 minus 2 would give us -53. One last time. 3 times -53 minus 2. That is going to give us -161.